Woohoo! We are live as I am adjusting things. This is Math 40. We're in 2.1. This is the second video, part 2, and we are solving equations. I made this lovely little helper card to remind me that when solving equations, I need to maintain balance, which means same thing on the left and the right. The first steps will be to add or subtract from both sides to move the terms. And then the second set of steps will be to multiply or divide to isolate the variable. So there we go, a little helpful card right there to remind me, and my support Godzilla right here. And let's go ahead and approach this guy. Woohoo! So I've got 7 equals -3 plus 2s. First thing we got to do is find the variable. I found it. Did you guys find it? It's like the easiest Where's Waldo, which is good because right now I could really go for an easy Where's Waldo, not the hard one. The variable is right there. Woohoo! So now I have to get that by itself. So there are going to be a number of steps. And remember that my first steps will be to add or subtract. So I want to move terms around. This is my variable term. So let me get rid of this -3. I want to check it over there on the left. But in order to do that, I can't just move it. I have to do something to both sides. Again, maintain balance. Same thing on both sides. Got to do something to both sides to get rid of the -3 or the -3. What do? You're right. I'm going to do the opposite thing or the inverse and add 3. So I had a -3, so I'm going to add 3. Okay, and remember, and you do not have to do the dotted lines if this annoys you, but remember to keep that little fence so that the left side stays on the left and the right side stays on the right. 7 plus 3 is 10. Woohoo! Now, -3 plus 3, this is a 0. You do not have to write in the 0. If the 0 helps, write it in. If it annoys you, leave it out. And then the plus 2s just kind of hangs out. I'm going to then, and you may already be at this point, but I'm going to go ahead. Oh no, what? Look over there. What? I think I see a pterodactyl flying by. What? There's no pterodactyl. Oh no, oh no. Oh, why does my whiteout leave? Oh, so sad. Let me see if I can try to make this make sense. Oh, that always happens. Okay, so 10 equals 2 times s. My brain thought s and then changed it to an x. Isn't that hilarious? Hilarious brain. Oh, man. Okay, so I've got my 2s there. And now I've gotten to the point where I've got one term on each side. So I can go to my next step. I'm going to multiply on both sides or divide on both sides to isolate the variable. So let me see. What am I going to do to both sides? I want the s by itself. It's multiplied by 2. So what am I going to do to undo that, to do the opposite thing? I'm going to divide by 2. But if I divide by 2 on the right, what do I have to do on the left? You got it. Divide by 2. So I've got 10 divided by 2, which is 5. Over here, 2 times s divided by 2. You don't have to write it in, but if it helps to remember, I'm going to cancel the 2's. And then I've just got s. S equals 5. Yay! Now, you can leave it like that, or you can write s equals 5 left to right style. Let's go ahead and just for the heck of it, let's just check. So checking means I take the equation, 7 equals -3 plus 2s, and I plug in what I think the answer is. And when I do this, I'm going to put a question mark over the equation, the equal sign, so that I know I'm asking, is this true? Okay, so I've got -3 plus 2 times 5. That's -3 plus 2 times 5 is 10. -3 plus 10 is 7. Oh my gosh, excitement. Check. It did in fact check. Woohoo, it worked. Woohoo, woohoo, woohoo. And let me see if I can so you guys can get a pretty screenshot if that's what you want to do. Sometimes whiteout just doesn't work. There we go. It'll be prettier when I scan it. So hopefully that'll help when I scan. Okay, so there's another one done. Yay, we're solving equations. Life is good. Da, 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 da. It's good to sing a little solving equations song for yourself. Da, 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 da. Okay, so there's my reminder page. Another equation. I know it's an equals equation because of the equals, but unfortunately, we've got a bigger issue here. Where's the variable? And the answer is, oh no. There are two different variable terms with variables in them. Oh no, what are we going to do? Well, what we're going to have to do is we're going to add or subtract to move the terms around. And we want to bring all the variables together. It's like members of the same family. We want to get them together. It's a nice little reunion. So in order to move them, I got to decide where I'm going to move them. Now here is a big, let me put it on a piece of paper so that I can convince you this is true. It doesn't matter what side you choose. Okay, there we go. There you go. It doesn't matter what side you choose. This is on one of these cards. These cards are sacred to me. This is absolutely true. It does not matter which side you choose. So if you want to put the A's on the left, put the A's on the left. If you want to put the A's on the right, put the A's on the right. As long as you follow the rules, as long as you keep the balance where you do the same thing on the left and the right. I'll even write left and right, just in case that helps people remember, left is this one, right's that one. As long as you follow the rules, you can put it on either side. Now, personally, I don't like ending up with negative numbers. It just bugs me. It's a personal thing. So when I decide how I'm going to approach an equation, I am always going to look for the side that has more of the variable. What do I mean? There are two A's over here. There's only one A over here. I'm going to go ahead and move all the A's onto the side with more A's. Okay. Now, some people say always move to the left, and that's fine, but they're a little wrong in that it doesn't matter. If you wanted to, you could solve it to the right as well. It does not matter. That's the great thing about equations. Okay, but I am going to move to the left, so I'm going to subtract this A to move this A, right? But again, if I subtract on the right, I have to also subtract on the left. And again, dotted line, unless you don't like it, in which case, skip it. Okay, so I've got 2A minus A, that's A. The 4 is just hanging out because it's not a like term, so it just kind of hangs there. A minus A, and again, if you cancel something completely, you leave a 0. Do you have to write it in? Absolutely not. You could also write it as A plus 4 equals 8. So far, so good? Awesome. A's are all together now. Happy little family reunion of A's. Yay! They're having a cookout, exchanging presents, probably playing silly games. It's awesome. However, the numbers also need a reunion. We need a reunion for the constants. Let's get all the numbers together on the other side. And again, it doesn't matter which side you choose, but once the A's are over here on the left, we want to move the numbers, the constants, onto the right. So I want to move this. It's a plus 4. So what's the opposite thing from plus 4? You're right, minus 4. And I do that on both sides. See, it's on the left and the right, the left and the right. Okay, I get an A because it's just hanging out. The 4 minus 4 is a 0, or leave that blank if you want. And then over here, 8 minus 4 is 4. So in other words, A equals 4. Oh my gosh, yay, we got the answer, woo, yay. And if you are concerned, if we had moved the A's onto the right, would we get the same answer? Absolutely. And in fact, if you're not sure, if you're like, I don't think that, go ahead and check it. Or come to office hours or go see a tutor and talk to them about it. We'll help you through it. We'll show you how it works. It's pretty awesome. Okay, let's go through and check. Remember that I always check the original problem. Just because I don't know if I made a mistake, it could have come in anywhere in here. So I'm going to go to the original, a plus 8, and I'm going to plug in my a equals 4. So I've put in my a equals 4, so I'm going to put that in wherever I see an a. And then remember, I personally do the question mark. That tells me I'm checking. Everybody has different ways of doing it. Not everyone writes it this way. Over here on the left, 2 times 4 is 8, plus 4 is 12. Okay, nice. And I learned to use little equals on the left. Here I've got 4 plus 8, which is, oh my goodness, are you guys excited? I'm so excited. Woohoo, it works. Now notice that the answer is a equals 4, but that it actually makes each side of the equation say 12. It won't say 4 necessarily. It might, but generally speaking, the answer won't match. What matches is the two sides of the equation have to match. They could be some really bonkers number like 148,000, but as long as both sides have the same number, you're good. Woohoo! Woohoo! Yay! Okay. You guys ready? Deep breath. We can do this. Get your support animal, bring it closer. The next one, not an easy one. You ready? Deep breath. We can do it. We can do it together. Yay, we can totally do this together. Are you excited? I'm very excited. Okay, so this one is, it's not the easiest in the world. This is fractions. Fractions make a lot of things very difficult, especially if you're a little rusty. And here I've got a bunch of fractions running around, but I noticed that all my fractions have the same denominator, 10, 10, 10. And I'm going to introduce you to a new concept, possibly. You may have used this before, but I'm going to suggest something called clearing fractions. So to clear the fractions, I need to take the denominator, which in this case is just 10, and I'm going to multiply everybody by 10. And you're going to say, what? Can you actually do that? And I'm going to say, yes, that is one of the rules. Now, I know this is supposed to be the last one, the multiplier divide, but you're allowed to do one of these in the beginning just to give yourself a nicer equation. So that's what I'm going to do. I'm going to multiply everybody by 10. And again, as long as I balance the left and the right, it's all golden. So what does that mean? I'm going to take the 10 and I'm going to multiply 10 times 8 over 10t. And I'm going to multiply 10 times 1. Oops, sorry, I wrote in the multiplication. Sorry, a little weird, but not wrong, just odd. Pretty much good description of me every day anyway. And then 10 times 15 over 10. Notice that, what color do I want to do? I like pink. Let's do pink again. Notice that I've got a 10 here, I've got a 10 here, I've got a 10 here, and I've got a 10 here. Everybody got a 10. Every term got a 10 on both sides. I didn't skip anyone. Yay! Okay, so it turns out, though, that 10 is not the best form because these are all fractions. So what I'm going to do with these three terms, I'm going to change my 10. I'm going to rewrite it as 10 over 1. Now I'm going to leave this one because 10 times 1 is not hard to work out in my head. But for fractions, I'm going to write things in fraction terms. You know, make sure that you're the math easier to do in each of these multiplications. So first case, what happens? The 10s cancel. Oh my gosh, that's so great. And what do I have left? I just have 1 times 8t, so 8t. Second, minus 10 times 1, that's minus 10. Okay, over here, oh, the tens cancel again. Oh my goodness, this is awesome. And I just have the 3t now. And then in the last one, the tens cancel again. Yay! So what did I do? All I did was I took this equation, which was a little bit intimidating because of all the fractions, and I said, you know what? I'm going to fluff it up. I'm going to fluff it up by 10. And so this number did get bigger by 10. And then basically, I'm just dealing with the numerators. Isn't that brilliant? I love clearing fractions because this is so much easier to look at. So I'm going to have to decide where the t's are going to go. It looks to me like I'm going to put the t's on the left because as I'm looking for my t terms, I've got a t term there and a t term there. There are more of them over here. So I'm going to move this over here. I've got a positive 3t. So how do I move it? I subtract from both sides. And then I get, let's see, 5t minus 10 equals, this zeroes out, so I've just got the 15. So 5t minus 10 equals 15. Nice. My variables are all together having their happy little variable family reunion. And then I want to give the same happiness to the constants or the numbers. So I want to move this minus 10 over to the number side. If it's minus 10, I got to do the opposite thing, which means I'm going to add 10 to both sides. Again, balance. Make sure you do the same thing on the left that you do on the right. Same thing on the left, same thing on the right. Make sure they are separated. So if I put the pen down where the equals is, I've got, oops, let's try that again. I've got 1 on each side, right? Put the pen down where the equal sign is, you've got 1 on each side. If they are both on the same side, then you're blowing it up and the whole teeter-totter is going to go sideways. So you got to keep it balanced. Same thing on both sides. Over here, 5t, these cancel, the minus 10 plus 10. And then here I've got 25. And then I've got my constant. Or sorry, let's try that again. No, I don't. I've got my variable over on the left. I've got my constant over on the right. And but I've isolated the variable. I haven't isolated it. I have a 5 there. And in fact, it's 5 times t equals 25. So what do I do to undo 5 times t? You got it. I'm going to divide both sides by 5. Again, staying on either side, 1 on each side, so it's legal. This cancels over here, and I get t equals 25 over 5 is 5. Woohoo! Now I'm going to need another piece of paper so I can do my check. Woohoo! This wasn't too bad. We did it. We did a really good job. So remember, t equals 5. Now for my check, I know this is a little bit painful because my check is going to be in the original. Always, always check the original problem. So what was my t? My t was 5. So in place of the t, I'm going to write 5 and 5. And then I'm going to say question mark. Now, since I'm dealing with fractions, I'm not just going to write it as 5. I'm going to write it as 5 over 1. So I took the 5 and I wrote it as 5 over 1. And this 5 as 5 over 1. Now, am I going to simplify? Because I could reduce, right? The 5 and the 10 cancel. I could. I have to decide whether I want to. Everything is in tens. So if I cancel, I might have a problem. But if we were in class, I'd say, hey, do you want to cancel? Do you want to not cancel? And everyone would yell yes or no. And so now I have to decide for myself. You know what? Let's go ahead and cancel. Why not? Here's the thing. only, when you're checking, only work on one side or the other side. So I'm just going to work here for right now. And I'm going to say, okay, the 5 and the 10 cancel. So then I've got 8 over 2 times 1 over 1 minus 1. This is just 8 over 2 minus 1. What is 8 over 2? The 2 cancels with the 8 and leaves, you got it, 4. So this is 4 minus 1, which is 3. And weirdly enough, I'm going to write the equals on the left-hand side because I'm just doing this side. So I'm ignoring the right. I'm saying, okay, if I put the 5 in on the left, I end up with a 3. This is our goal for the right. We're hoping we get a 3. So now let's work over on the right-hand side. Since we did cancel over here, I'll cancel over here. Cancels there. Okay, this is not as nice. This is 3 over 2 times 1 over 1 plus 15 over 10. And then I go, wait a minute, I can reduce this one too, right? 15 over 10, let's see, 5 goes into 15 3 times. 5 goes into 10 2 times. So I've got 3 over 2 plus 3 over 2. I can add those. That's 3 plus 3 all over 2, which is 6 over 2, which is, oh my gosh, I'm very excited. Are you excited? Are we excited together? Woohoo! Yay! It works! Check! Our problem worked. You guys are brilliant. We made it through a hard problem. Yay! Next up, a bunch more hard problems, because the best way to learn something is to practice and face your fears and woohoo! So, as soon as I see you in the next video, I'll see you. There's a brilliant tagline. Woo, guys, and math on.